Hi guys, so I'm going to do something a little unconventional. I'm sure you've seen a bunch of PowerPoint slides today and you're tired of them, so we're going to do this all in the IPython notebook, but it'll be very visual and it'll be fun, because it's the end of the day. So I have an IPython notebook. I've got a couple demos up for you guys. I'm going to start by just saying who I am. I'm Katherine Scott. I'm the director of R&D for a company called SimpleCV, and we make a product called SimpleCV, which is just a library for computer vision. And if you don't know, computer vision is basically anything where you take an image from a camera, you make it into bits, you distill those bits, and you get some sort of result that you find useful. So like in the case of my card, I can just say, hey, take that image of that card and read the text from it. Oops. And you get something like that, which is pretty helpful. So the question we get all the time is, well, is SimpleCV OpenCV? And the answer is kind of. It's not exactly. We take their bindings, we clean them up, we present them in a way that makes it easier to solve problems, and we pull in all this other stuff from the Python ecosystem to make it work well and be fun. So that means pulling in Pill and NumPy and SciPy and Pygame and Orange and just hundreds of different libraries basically. And then we try to make it easy to learn how to use all these things to do cool stuff. So what that ends up meaning is that you start by creating a web page and saying, hey, I got this project, putting all your documentation up there, making sort of super packs that install everything clean. Then you start creating a forum, and you go and you find the people who are using your library, and you ask them what they need and what they're doing with it and how you can help. And then you write a book and you kind of start to develop coursework around it, so you can take young people who are just getting started and really get them excited about doing really interesting, fun stuff with computers. So you also write your library in a way that makes it easy to use. So you write lots of documentation that you can just pull up and use while you're coding. We kind of have an edict basically where we'll write one line of documentation for every line of code, just so it's easy and accessible. You also support all the platforms that people want to use it on. So all of you got Raspberry Pis. We run on Raspberry Pi. I'll be in room 202 at 4 o'clock tomorrow for a few hours. If you want to put SimpleCV on your Raspberry Pi, I'll be there to help. And if you're not going to be there, we have the directions up on GitHub if you want to run SimpleCV. So if you want to go home, take your Raspberry Pi, grab a camera, and make a home security system, or make a system that tweets when your dog eats its lunch, we got you covered. All right. So I flew in this weekend from Michigan, which is this beautiful state right here. And we actually call it the Third Coast, because we like to think we're really important, because we have all these beautiful lakes that I will highlight here for you, using just a little bit of code. In Michigan, where you come from kind of dictates what you do and why you do it. So in Michigan, one of the big things is manufacturing. So I'm going to download what Google thinks manufacturing looks like here. And you see all these sort of problems where people are building stuff and they have tolerances. And you have people looking at parts to inspect them and make sure their quality is correct. So we're building SimpleCV to help us solve these problems. And we have a company that's behind that, which is SimpleCV, and we're working with customers in the Midwest to solve these sort of problems. So we do stuff like use computer vision to look at industrial bolts that hold your car together and keep your motor from falling out of your car. We also do stuff with working with farmers. So this is a live feed of a fish farm in Tecumseh, Michigan. And we have a Kinect hovering above this one of the pools in this fish farm, if it'll come up. And we're looking at the fish and we're trying to figure out how they're moving and what they're doing and when they're hungry and why they're hungry. Because when you're a fish farmer, the food that you feed your fish is really important. It's your biggest cost, and the labor to feed them is also your other biggest cost. So we want to help them make that easier and quicker. And so the fish look like this. This is a northern pike. And it turns out if you overfeed them, right, they get kind of sick. And if you underfeed them, they don't grow or they die. You don't want fish like this. This is a good image processing problem, right? So I guess in the grand tradition of computer vision, or in programming, like how do we write our first computer vision application? So I'm going to switch over here, and I have a Hello World app for you guys, and it's just SimpleCV. I grab an image, grab a display, grab a color class and a camera class. I say, hey, give me a USB camera and then give me a display, and while I say don't quit, grab images off the camera, apply a binarize filter to them, which just makes it into a black and white image. I draw some text on it, and then I show it. And that looks like, and here you go. So here's your hello world doing image processing. And you're like, okay, well that's kind of cool, right? But we can do a little bit better. So I have another one here. So it's not just webcams that we can do. We can do all manner of camera. We do scanners, Kinects, professional machine vision cameras, DLSRs, all that stuff we basically support. So a common one is a JPEG streaming camera, which would be your basic IP camera. And you can download, say, an app for your iPhone or for your Droid that will turn it into an IP camera. So I have a little script here that basically reads from an IP camera, streams it to a web browser viewer, and does just a little bit of image processing. So I can go like this, and hopefully demo God's willing. I got my phone over here. So here's me, here's my cell phone, here's a web browser, and I am just doing basically real-time processing through it. Yeah, pretty fun. So let's get down to the meat and potatoes of like how SimpleCV kind of works and how you frame problems. So I pulled down an image the other day, and this was in our tutorial. Oh, it's worth noting our tutorial is all online, so if you guys want to try it and get the full 4 hours of SimpleCV, you're more than welcome. So I have this picture of cookies that somebody baked, and they took a long time icing them. It's a good image too, it's got a nice even background. So I'm going to ask SimpleCV to basically look for bright areas to find the blobs in the image and return the bigger ones, and then color them red and show it to me. So that looks like this, which is pretty good. So I got most of the cookies, I got some weird sort of specular stuff going on here. So I'll filter that out, and I filter that out by saying, hey blobs, tell me how big each of you are, and I'm going to use NumPy to figure out the mean, the average size of the blob, and the standard deviation. And then I'm going to say, okay, blobs, filter out all the blobs where the area is just a little too big, and return another list of blob objects, and color those green. So that looks like this. All right, well, let's say I wanted to grab one of these cookies. Let's say I wanted to grab this yellow star one up here. So let me see if I can find the yellow cookies, and I'm going to say, for all the little tiny cookies, sort them by their color, and sort them by how far they are away from yellow, and show me what those look like. All right, so those are the 4 most yellow cookies. Okay, so I still want this one in the upper right-hand corner, so how do I get at that one? Well, so I basically say, how far is it away from the upper right-hand corner, which is a certain width and a y value of 0, and I say, well, just show me where that distance is minimal. Crop out that one cookie, and then draw it in hot pink. And that looks like this. Cool, so I just found the cookie just programmatically, and that's pretty easy. So another sweet sort of thing you can do in mobile robotics, I coach a first team, and you want to teach them to train the robot to drive down hallways. And part of what you do to do that is you look for doorways, because those are good defined, and you look for vanishing points, because that kind of defines where you can go. So I have an image of a hallway, which is probably like the hotel you're staying in right now, right? And I can use an edge filter, a canny edge detector, to look at the edges in there, which looks like that. And then I can ask SimpleCV to say, hey, will you find the lines in this image, all the straight lines, and then filter them out so that I only get the longest ones. And you get something like that. And that's pretty good, okay. But I want to find where the doors are, I want to find the floor, and I want to find the vanishing points. So we should break these out a little bit. So I can break them out just in the same way I sorted those blobs. So I can ask questions like, hey, filter out just the vertical lines, or the lines that have an angle greater than 80, or the lines that have that are horizontal, that have an angle less than 10 degrees. And I can draw those as different images. And that looks like that. So you can see how you can kind of build up these primitives to solve problems in an interesting way. All right, so a good crowd pleaser is always doing face finding. So we have this all sort of baked into SimpleCV. So I'm going to try to find a couple faces here using what we call a HAR cascade or a HAR feature. And these are like pre-trained bits of machine learning that automatically find stuff for you. So I'm going to pull up a couple images, Here's one of Richard Nixon, and here's one of Picard. And see, face findings seem to have found them, and it's drawn a box around them. So immediately when you start looking for faces, people want to start having fun. So I define this function over here that's called swap. And it takes in an image, or it takes in two images, and it takes in two faces. And I take one face, I get just the face image, and I resize it to fit the other image, and then I do the same for the second image. And I use a command called blit, which just moves bits around between images, and I can swap. This one's funnier. So people really like looking at other people. It's one of those things, half your pictures that you take are going to be of other people. So we try to make sure we have tools that let people play in that sort of way. So I had one of my Google Summer of Code kids write a fine skin tone area finder for SimpleCV. So you could just, if you want to say track hands or track feet or just track people in general, it can help you do that. And it's just the same way of finding blobs. You just say find skin tone blobs, and it does it automatically for you. So I'm going to find the blobs, I'm going to color them green, I'm also going to give it a little bit of an alpha blur. And then I'm also going to list the other things I can find, so I'll show you that. And that looks like that. So I also have a list of what else I can find here. So I can find profiles, eyes, two eyes small, faces, upper bodies, mouths, ears, all these different things. So I'm going to try to find a mouth here. And then I'm also going to load this image in. You guys can read ahead and see what I'm doing here. I'm going to take this image, I'm going to resize it to the width of the mouth. And SimpleCV will infer the height, which is nice. And then I can take the location of it, scooch it up just a little bit vertically, and then basically move that image in using an alpha mask. And then I'm also, just for fun, I'm going to grab one of the eyes, the right eye, and I'm going to draw a circle. And that's going to look like this. So this is all cool, and Python makes it really easy to just do fun stuff once you can find faces. So you guys seen any of these Tumblrs or like the Reddit where they have the reaction GIFs where people are doing something kind of interesting or cool, or they're just like, I'm angry, so look at this clip from a video. So I wrote one of these the other day, and I'll call it myfacewin.py. I pulled in an Imager API key so I can just upload things automatically to Imager. And what I'm going to do here is I'm going to create an image set, which is just a list of images. And I'm also going to try to count the number of faces I find. So I'm going to get a certain count of faces from my camera. And if I find them, I'm going to draw them to the screen. And then I'm also going to resize them to a smaller size just so it's easier. And once I get enough of them, I'm going to tell SimpleCV to save them as a GIF file altogether and then upload it to Imager and open up my browser. So this, oops, go over here. So it'll look like this. Hopefully I have it at work. And that is my face when I was speaking at PyCon. So, you know, little toy things like this are a lot of fun. I also have another one here. So we found lines, we found faces. There's also temporal things you want to find. So you want to track things in videos, you want to look at motion. So I have just a really quick motion demo. It's just a couple lines. So basically all I do is the same thing I've been doing before, is I create a camera and a display. I get images from the display, scale stuff, you know, move it around. And then while the display's not done, I just look for motion using this find motion command, and I draw it to the screen, and I save it. So that looks like oops. And you get this sweet kind of trippy display where you get the tails over the motion in a certain area. So this is pretty useful because you can use it to like track animals or look for something happening in an otherwise still video frame. So back here, so let's go back to the notebook. So this is just purely scratching the surface. You can tab complete in my Python notebooks, which is awesome. So here are all just the find methods in SimpleCV. So you can find barcodes if you need to read QR codes or regular barcodes, if you need to look for blobs of a certain color or from a mask image. Chessboards are good for camera calibration. Circles, corner points, features, grid lines if you're looking for a grid. Key points, which are these SIF, SURF, orb, sort of really cool computer vision things for finding and recognizing stuff. Lines, motion, skin tones, and templates. Templates are little tiny image samples that you can kind of use to find stuff. So, you know, it's 5:30, it's the first day of PyCon, so there is exactly one thing on your guys' mind right now, and that is machine learning, right? It's exactly where you want to be. So this morning I pulled down a bunch of images from Google and I searched for 3 things: beer, wine, and whiskey. I downloaded 40 images and I split them into 2 chunks. One is a training chunk and one is a testing chunk. And what I do with those chunks is I'm going to create a couple of machine learning tools to hopefully recognize beer, wine, and whiskey images. So to do that, I create what we call feature extractors, and all these do is distill a big, huge image down to a few numbers that we can use for machine learning. So I know that these things look different in terms of color, like wine's usually purple and beer's hopefully yellowish. So I'm going to use a hue feature extractor, which just looks at the hue, which is the color. I'm also going to, I know that beer steins are kind of like this, and wine glasses are kind of like that, so they're curvy, so I'm going to use edges. So basically the histogram of edge angles. And then I'm also going to use HAR features, and these are kind of like these simple calculations to look at symmetry in an image, basically. And I'm going to put these all together into a list, this list of extractors, and I'm going to give these extractors to a support vector machine and a tree classifier, and I have, I've set these so they usually have pretty good starting parameters. You can tweak them to get better performance. And then I'm going to point to the directories where I've saved all my images. And I'm going to tell the classifiers what I'm looking for. So wine, beer, and whiskey. And all I have to do is tell my classifiers to train on a set of data and show me what's going on, and then test on another set of data and see how that responds. So that ends up looking just like this. And it's going to chug along for a minute. Not too bad, though. It's not too much data. So here's the first one's done. It got 91% training itself, and here's a confusion matrix that just tells you how it's doing. Here's the tree, and it also, that's 91. And here's the production, I think this is the SVM, and it got 77.7% on its testing data. And here's the tree, and it got 82%, so I think we should use the tree to actually see what's going on. And these numbers aren't fun. We all deal in numbers every day, but seeing what actually is going on is a lot more interesting. So what I'm going to do is I'm going to take random in here. I'm going to create an image set, and I'm going to train that image set, or I'm going to take that image set and I'm going to fill it up with my testing images. And then I'm going to randomly shuffle it just a little bit and pick 10 at random, and I'm going to use my tree classifier, get what it thinks they are, and put that name on the image. So let's see what it does. And it looks like, we had one mess up, but 9 times out of 10, it's doing 80% is pretty good for this kind of task. So I really would like to test this in the field. Deployment is everything, right? If you don't ship. And so that's all I have, but I'm here to ask, answer some questions and help you guys out. So.
So, if you have a question for Katherine, can you either go to that microphone there in the aisle or come up to me?
Hi, you said there was a library for the Raspberry Pi. I'm just wondering, is it very performant, and are there any restrictions because of the device?
So we should have an image up soon. We have installation directions, right? So it's a Raspberry Pi. It is a performance-constrained platform. So it's not, we can do, like, if you shrink your image down to, like, 320 by 240 and do simple stuff, yeah, it'll work really well. And for basic calculations, too, as long as you're not going to do real-time hardcore stuff on it, but it works.
Cool. Over in the other aisle.
Is it possible to take the features that you just learned for classification and kind of visualize an beer or an whiskey or an wine?
What was that last part?
Visualize sort of an average wine or an average whiskey or an average beer?
You really could, actually. So what you would do is you'd create an image set right on the classification, and there's actually an image set average function, and you would have to scale them all so they all fit together, but you can create an average image of that.
But would that be the features? But would that use the features that you'd learned, or would that just be an average of the?
Can you say that again?
I was wondering if you could visualize more precisely the features that you'd learned instead of just averaging the images together.
So you could visualize the features. Like HAR is just essentially like you'd take the right and left side of the image and subtract the one from the other and sum everything up. It's a quick calculation, but it's a good back of the envelope on symmetry. And you definitely can visualize it. You can get that data out from the feature extractors.
Yep.
What kind of support do you have for dealing with things like text and handwriting? Could you use this to maybe train it to recognize like somebody's signature or something?
So handwriting. The question is, can you do handwriting recognition? The short answer is we don't have a library or utility to do that. If you wanted to, I don't think it would be exceptionally difficult, but the tools would be in there, because all you need to do is find the lines on the actual signature and try to come up with an algorithm that would match the points on those sort of contours of a signature.
Okay.
Yeah.
Cool. Any more questions? Well, in that case, please join me in thanking Katherine. And I think that's it for today's talks, so we'll see you bright and early tomorrow morning.